There is a quiet revolution happening in software development right now. Junior developers are generating production-ready code in minutes. They are asking for entire features and receiving them instantly. It feels like magic. But beneath the surface of this productivity boom, a dangerous pattern is emerging. We are looking at a cohort of developers who have learned to code exclusively through artificial intelligence. And here is the thing. In about 5 years, this approach is going to hit a wall. To understand why, we need to look at how learning actually works. When you learn to build a house, you do not just watch someone else lay bricks, you lift the hammer, you mix the cement, you feel the weight of the materials. You understand why the foundation needs to be deeper in certain soil types. This tactile experience builds intuition. Now consider this. When a junior developer relies entirely on a large language model to write their code, they are skipping the lifting of the hammer. They are getting the result without the process. Let me paint a picture of two developers starting their careers at the same time. Both are given the same task: build a simple user authentication system. The first developer, let us call him Alex, uses artificial intelligence for everything. He prompts the tool, copies the code, pastes it into the integrated development environment, and moves on. If the system crashes, he asks the tool to fix it. He never writes a line of logic from scratch. He treats the code like a black box. The second developer, let us call her Sam, also uses the assistant, but she treats it like a junior colleague. She reviews every suggestion. She writes the logic herself first, then compares it to the output. She understands the flow of data. 5 years later, the difference becomes stark. Alex is now a mid-level developer. The company asks him to refactor a legacy module that has grown complex. The tool suggests a change. Alex accepts it because he trusts the tool. The code runs, but the underlying architecture is brittle. There are hidden dependencies that Alex does not understand. When a new requirement comes in, he cannot extend the code because he does not know where the boundaries are. He is stuck. Sam, on the other hand, faces the same task. She knows how the authentication logic connects to the database. She sees the architectural debt accumulating in the codebase. She can trace the flow of information. She can explain to her team why a certain change will break the system. She has the mental model that the tool cannot give her. This is the core of the problem. Exclusive reliance on the tool creates what we might call invisible architectural debt. It is invisible because the code works. It passes the tests. But the understanding required to maintain it is missing. Research from major technology firms suggests this is not just a theoretical risk. Studies indicate that while the tool boosts short-term productivity, it risks eroding fundamental cognitive skills. The link between code production and deep understanding of algorithms and data structures is breaking. For Alex, the scaffolding effect of the tool created a false sense of competence. He could generate code, but he could not explain, verify, or optimize it. In a high-stakes enterprise environment, this is a critical weakness. Now consider the debugging process. When a human writes code, they make mistakes. They learn from those mistakes. They know why a variable is null. They know why a loop is infinite. When the tool writes code, it is often correct, but it is also sometimes hallucinating. If the tool suggests a solution that works by accident, the developer never learns the root cause. They patch the symptom. Over 5 years, these patches accumulate. The system becomes a patchwork of suggestions that no single person fully understands. This leads to a mentorship bottleneck. Experienced developers struggle to identify and correct superficial understanding that mimics proficiency but lacks depth. When a mentor asks a junior, "Why did you choose this data structure?" the junior answers, "The tool told me to." The mentor cannot teach what the junior does not know. They do not know. This is the gap. The future of junior development will shift from syntax acquisition to orchestration and validation. But you cannot orchestrate what you do not understand. We are seeing a shift in educational models. Current programs that integrate the tool without enforcing rigorous manual coding requirements are producing a cohort of developers who lack the resilience and problem-solving intuition needed for long-term career growth. They are not obsolete yet. The market is still hungry for bodies who can ship code quickly. But as the technology matures, the demand for basic generation will drop. The value will shift to those who can validate and direct the tools. Imagine a scenario where the model changes. Or imagine a scenario where the tool generates a security vulnerability that is subtle. Without deep knowledge of the underlying logic, the developer cannot spot it. They are flying blind. In 5 years, the developers who only learn to code via generation without understanding the underlying logic will face severe obsolescence. They will find themselves unable to adapt to new frameworks or legacy systems that require human intuition. The solution lies in how we approach learning. It is not about banning the tools. It is about using them as a tutor, not a replacement. You must verify the output. You must write the code yourself before asking for help. You must understand the algorithms. This builds the resilience needed for the long term. The goal is not to compete with the machine. The goal is to become the architect who knows when the machine is wrong. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.